Everyone, I'm Doug Black, Editor-in-Chief at Inside HPC, and during the SC22 conference, we're speaking with Jeff McVeigh. He is Corporate Vice President and General Manager of Intel's Supercompute Group. Jeff, welcome.
Thanks, Doug. Good to see you.
Good to see you again. Okay, so Intel just announced the Max CPU and GPU series, along with the fourth generation Xeon Scalable Processor. Tell us about these new technologies.
Yeah, we're really excited about this portfolio of products. We feel it's our strongest lineup of products for the HPC community in literally many years, even if not a decade. Let me start with the fourth generation Xeon Scalable Processor. This is previously codenamed Sapphire Rapids. Brings together our most advanced x86 core. We add significant accelerators for AI processing with AMX, data streaming acceleration, security. All those things are necessary. So it's not just all about the maximum number of cores you can have, but what the value of those cores deliver in terms of their application performance and how they can really deliver that value. Now, the Max series CPU, previously known as Sapphire Rapids with HBM, brings together the Sapphire Rapids architecture with high bandwidth memory. And our whole goal there is really to balance out the system for codes that are memory bandwidth bound. So it's not just about delivering the compute, but feeding that compute engine with enough memory bandwidth. And we're seeing fantastic results with work at real world workloads in terms of the performance that delivers. Finally, the Max series GPU, previously codenamed Ponte Vecchio, is our flagship GPU in the HPC and AI space. And this is really delivering densest compute, vector matrix processing support, be able to do a variety of workloads and really advance the capabilities. And we use the term max really to signify that these are the maximum performance across our CPU and GPU lines and how they come together into an overall portfolio.
Okay, so tell us how these new technologies benefit customers.
Well, for us, it's all about delivering the workload performance that helps our customers solve the world's most challenging problems. So putting aside some of the specs or even the benchmarks, we're seeing, as an example, with the Xeon CPU Xeon Max CPU, 2, 3, 4 times better performance on real workloads relative to both prior generations and competitive platforms in market. And that delivers obviously huge value in terms of time to solution, energy efficiency, being able to do new science based on the performance that those deliver. That's on the CPU side with the Max. The Sapphire Rapids fourth generation by itself delivers great generational improvements as well. And now Intel has a portfolio that spans CPU and GPU. For a long time, we've been very focused on our CPU legacy and assets there. And now bringing forward a full portfolio across the CPU and GPU delivers even more performance for those workloads that really have that dense compute that can be effectively offloaded to a GPU and to again deliver that workload performance.
Okay, so in this CPU GPU environment, talk about Intel's oneAPI and how that helps customers take advantage of these heterogeneous technologies.
Yeah, that's a great point that ties it all together. And maybe I can step back a few years even about how we started here. Back in 2017, 2018, we knew that we were going to be delivering CPUs and GPUs as well as other architectures to market. But we also realized that it's important to have uniformity for the programming model. The Xeon software ecosystem is vast. Pretty much every HPC code runs on the CPU today. Some of them have been effectively offloaded to GPUs, but up until now, they've been primarily in a vendor lock-in programming environment. What we want to do with oneAPI is to provide a standards base, so language support with SYCL, library base with APIs and interfaces that anybody can implement across architectures to help those codes be migrated from both the CPU to the GPU, but then also the additive value between them. And having a common programming construct, common kernel language support, common libraries, and then how those plug into popular frameworks. In the AI space, TensorFlow, PyTorch, obviously, but then also into other frameworks that are used by the community, while also supporting legacy languages, Fortran with OpenMP offload, and so forth. And that's how oneAPI really brings together that foundational capability that then is plugged into middleware and frameworks above, so that application and end users can continue to use what they're most familiar with. So oneAPI is really the glue that provides the commonality across those architectures. And just re-emphasizing the point about being open, we've seen and also we're supporting its implementations across other GPU vendors from AMD and NVIDIA, as well as other CPU vendors, again, AMD as well as ARM. So for us, it's all about making sure that developers are productive and can achieve performance in a productive manner, not just on Intel platforms, but across the entire ecosystem.
Okay, interesting. So now Aurora, Intel's exascale-class supercomputer going in at Argonne National Lab. Argonne's Tim Williams reports that Sunspot, which is the Aurora testbed, has been installed. What else can you tell us about that?
Yeah, it's great. It's great that we have the testbed in place. Developers are utilizing that. This is great feedback from SC, talking with the people on the keyboard writing the code, that they see great stability with the software, that they see early performance results that are very encouraging. Now we know that we need to scale that out beyond the 128 nodes to over 10,000 nodes, so we've got a long way to go there. But the work on Sunspot is critical. On the bigger system, we're delivering our production nodes today. Just to remind the audience, those include 2 of the 4th generation Xeon Scalable Processor. We'll upgrade those to the Xeon Max CPU in next year, and then 6 of the Xeon, the Max GPUs as well. So Ponte Vecchio. So 2 CPU, 6 GPUs on each node. So we're actively delivering the production versions of those. Every day there's another pallet of blades being delivered into Argonne and being installed. So we'll have more news about the results on that next year, but it's very exciting to be in production, delivering those, staying those up, getting that stabilized, and then utilizing the great workload results that we're already seeing on Sunspot, and then bringing that to the broader system.
Excellent. Yeah, I was actually out at Argonne 2 weeks ago in the Leadership Computing Facility and saw that process ongoing. It was great to see. So Jeff, thanks so much. We've been with Jeff McVeigh. He's head of Intel's Supercompute Group, and we'll talk to you again soon.
Thanks so much, Doug. Take care. Bye-bye.